Right now, at the bottom of the North Atlantic Ocean, roughly 600 kilometers south of Newfoundland, there is a ship. It has been there for more than a century. It sits in two pieces on the ocean floor, 3,800 meters below the surface, in water so cold and so dark that no sunlight has ever reached it, in pressure so immense that an unprotected human body would be destroyed in seconds. The ship's name is Titanic, and for 73 years after it sank, no one on Earth knew exactly where it was. It was supposed to be the ship that could not sink. That is not a myth invented after the fact. That was the genuine belief of the people who built it, the people who sailed on it, and the people who bought tickets to cross the Atlantic on its maiden voyage in April of 1912. The Titanic was not just a ship. It was an argument that human engineering had finally, definitively conquered the ocean. It was wrong. And the way it was wrong, the specific, catastrophic manner of its failure, sent more than 1,500 people to the bottom of the sea and left a wreck on the ocean floor that would become one of the most searched for objects in human history. But before we descend to where it lies, we need to understand what it was, because the Titanic was not simply a large ship that sank. It was the product of an era that believed, with genuine conviction, that there was no engineering problem the human mind could not solve. And that belief, that confidence, that certainty is as much a part of what happened on the night of the 14th of April, 1912, as the iceberg itself. If you enjoy drifting into the deep ocean and discovering what lies beneath, please consider liking and subscribing. It truly helps more than you know. Are you ready? Let's begin. The year was 1907. The White Star Line, one of the dominant transatlantic shipping companies of the early 20th century, was losing ground to its primary competitor, Cunard, which had recently launched two ships, the Lusitania and the Mauretania, that were faster than anything White Star could offer. White Star's chairman, J. Bruce Ismay, met with the shipbuilder William Peary, chairman of Harland and Wolff in Belfast, and together they devised a response. Not speed, size, luxury. 3 ships of unprecedented scale, the Olympic, the Titanic, and the Britannic, each one larger than anything ever built, each one designed to offer a crossing experience so comfortable, so magnificent, that speed would seem beside the point. It was a strategic decision as much as an engineering one. White Star would not compete with Cunard on Cunard's terms. It would change the terms entirely. The Titanic was the second of the 3. Its keel was laid in Belfast in March of 1909. Over the next 2 years, more than 3,000 workers labored on its construction, a workforce so large that the shipyard had to be significantly expanded just to accommodate the project. The ship that emerged was 269 meters long, nearly 3 football fields. It displaced 52,000 tons of water when fully loaded. Its engines, 3 massive steam-driven systems, could generate 46,000 horsepower. It had 840 cabins spread across multiple classes, a gymnasium, a swimming pool, a squash court, a Turkish bath, a Parisian-style cafe. The first-class dining saloon could seat 550 people at once and was modeled on Jacobean architecture, with oak paneling and plaster ceilings of a kind found in English country houses. The first-class grand staircase, with its carved oak banisters and wrought iron scrollwork, descended through multiple decks beneath a glass and iron dome. It was photographed so extensively during the fitting-out period that it became one of the most recognizable interior spaces of the early 20th century, and it has remained so. The ship was designed with a system of 15 watertight compartments, divided by bulkheads that could be sealed by electrically operated watertight doors. In the event of flooding, sections of the ship could be isolated from each other, containing the damage. The naval architects calculated that the ship could stay afloat with any 2 compartments flooded. It could remain buoyant, their models showed, with any 4 compartments open to the sea simultaneously. This was the technical basis for the claim, which appeared in promotional materials and in the trade press, that the ship was practically unsinkable. Not a boast, exactly, a calculation. A mathematical argument based on the best engineering of the time. The ocean had always had the advantage over ships. Now, the engineers believed that advantage had been neutralized. The Titanic was designed to survive whatever the North Atlantic could throw at it. That belief was sincere, and it was wrong. The Titanic departed Southampton on the 10th of April, 1912, at noon. Crowds lined the docks. The departure of a ship like this was an event. Passengers had traveled from across Britain and Europe to board it. Others had been waiting in Southampton for days. The ship moved down the river Test and into the Solent, and as it passed, the wash from its enormous hull caused a smaller ship, the New York, to break its moorings and swing toward the Titanic's side. A collision was narrowly avoided. Some of the watching crowd noted this as a bad omen. Others laughed. The Titanic continued on. It stopped at Cherbourg in France that evening, then called at Queenstown, now Cobb, on the southern coast of Ireland, on the morning of the 11th of April to collect final passengers and mail. Then it turned west into the North Atlantic. On board were 2,224 people, passengers and crew. The passenger list represented an almost perfect cross-section of the social world of the early 20th century, arranged by class with a precision that the ship itself enforced architecturally. In first class were some of the wealthiest people in the world. John Jacob Astor IV, one of the richest men in America, traveling with his young wife Madeline. Isidor Straus, co-owner of Macy's department store, and his wife Ida, who would refuse a lifeboat seat rather than leave her husband of 40 years. Benjamin Guggenheim, who would change into evening dress before the end, remarking that he intended to die like a gentleman. Sir Cosmo and Lady Duff Gordon. Margaret Brown, the Denver socialite who would later be known as the unsinkable Molly Brown. Their suites cost the equivalent, in today's money, of $60,000 to $100,000 for the crossing. They had a private promenades, personal servants, access to every amenity the ship offered. In second class were professionals, teachers, clergy, minor businessmen, making a respectable but not extravagant crossing. And in third class, which was nonetheless cleaner and more comfortable than the steerage of older ships, were the emigrants. families from Ireland, Scandinavia, Lebanon, Eastern Europe, Finland, Croatia, many of them carrying everything they owned, many of them crossing to America with no contacts and no prospects, just the belief that it would be better than where they had come from. They were separated from the upper decks by locked gates and unfamiliar corridors and the language barrier of a ship whose officers spoke only English. They were at the bottom of the ship's social hierarchy, and they were the ones who would die in the greatest numbers. The crossing began without incident. The North Atlantic in mid-April can be severe, but the weather in the first days was unusually benign. The sea was calm. The sky was clear. The temperature was dropping as the Titanic moved westward and northward into higher latitudes, but the air was still, and the ship made good speed. There was, however, a problem developing that few on board were fully aware of. The spring of 1912 had seen an unusually heavy iceberg season in the North Atlantic. Warm currents from the south had broken up the ice of the previous winter and sent enormous quantities of it drifting southward into the westbound shipping lanes. On the 14th of April, the Titanic received at least 6 wireless messages from other ships reporting ice in the area ahead. Some of these messages were recorded and posted on the bridge. Others were intercepted by the wireless operators, Jack Phillips and Harold Bride, who were occupied primarily with transmitting commercial messages for passengers and were not formally relayed to the officers. The ice warnings were known. The ship did not slow down. This decision has been analyzed, debated, and condemned for more than a century. The most straightforward explanation is also the most damning. Speed was a priority. White Star wanted the Titanic to make a strong showing on its maiden voyage, and arriving in New York ahead of schedule would have been significant. There is some evidence that Ismay, who was on board, had discussed the possibility of arriving early enough to make the evening papers. Whether or not that specific pressure influenced the decision, the ship continued at close to full speed through waters that other ships were navigating more cautiously. The night was dark and calm. Too calm, as it turned out. In rougher weather, breaking waves at the base of an iceberg would have made it visible from a greater distance. On that flat, moonless night, the ice was invisible until it was very close. At 11:40 p.m., Lookout Frederick Fleet, stationed in the crow's nest, saw a dark shape ahead. He rang the warning bell 3 times and reached for the telephone. Iceberg, right ahead. On the bridge, First Officer William Murdoch ordered the helm turned hard to port and simultaneously ordered the engines reversed and the watertight doors closed. The Titanic began to turn. It was a large ship, and it did not turn quickly. The iceberg was too close. The ship struck the ice along its starboard side in what felt, to most passengers and crew, like very little. A slight shudder, a grinding vibration that lasted perhaps 10 seconds. Some passengers sleeping in their cabins did not wake up. Others, who were still up, felt it and went back to what they were doing. A few who were on deck saw the iceberg pass alongside the ship, close enough to touch, and then disappear into the darkness astern. It did not seem like a disaster. It did not look like one. But below the waterline, along approximately 90 meters of the starboard hull, the iceberg had done its work. It had not torn a single long gash, as was long believed. The actual damage, revealed by later examination of the wreck, was a series of small punctures and buckled plates in the seams between hull sections, openings that collectively were smaller than you might imagine. Perhaps a total area equivalent to a few sheets of paper, but they were in the right place, or rather, the wrong place. 6 of the ship's watertight compartments were open to the sea. The design allowed for 4. Thomas Andrews, the ship's chief designer, who was traveling on board for the maiden voyage to observe the ship's performance and note any adjustments needed, was called to inspect the damage within the first hour. He went below with Captain Smith and worked through the arithmetic quickly, the rate of flooding, the ship's buoyancy. The math was not complicated. The bow would continue to ride lower as the flooded compartments filled. The water would eventually reach the tops of the bulkheads, which did not extend to the full height of the ship, and spill over into the next compartment and the next. The ship would sink bow first, slowly at first, then faster. Andrews told the captain and the officers gathered around him in the chart room what his calculations showed. The ship had perhaps an hour and a half, 2 hours at the outside. The order was given to uncover the lifeboats and begin loading passengers. It was 12:05 a.m. on the morning of April 15th. What followed over the next 2 hours and 15 minutes has been reconstructed from the testimony of survivors, from the wireless messages exchanged with other ships, from the logs of the rescue vessel Carpathia, and from more than a century of historical and forensic investigation. It was a process of organized and disorganized tragedy unfolding simultaneously. The lifeboats were lowered. There were 20 of them, with a total capacity of approximately 1,178 people, or roughly half those on board. This was, remarkably, more than the minimum required by British maritime law at the time, regulations that had not been updated since an era when ships were much smaller. The Titanic was legal. It was catastrophically inadequate, and many of the lifeboats were launched less than full. Lifeboat 7, one of the first away, had a capacity of 65 people and left with 27. Officers on the boat deck were reluctant to load boats to capacity, partly because they feared the davit mechanisms might not hold a fully loaded boat, partly because they did not fully believe, even then, that the ship was truly sinking. Passengers in first class, who had the most immediate access to the boat deck and the most social authority to demand priority, often refused to board, not wanting to leave the warm, lit ship for a small, cold lifeboat on a dark ocean. Third-class passengers, many of whom were unfamiliar with the ship's layout, and some of whom did not speak English, had difficulty even reaching the boat deck through the maze of corridors and locked gates below. The social structure of the ship, which had kept the classes so carefully separated during the crossing, now sorted them by survival probability with brutal efficiency. At 2:17 a.m., the power finally failed. The lights went out. The ship had been tilting forward throughout the 2 hours of its sinking, the bow riding lower and lower as the stern rose higher and higher out of the water. By the final minutes, the stern was nearly vertical. The ship's massive propellers lifted clear of the ocean, visible briefly against the dark sky. Then, under stresses that the hull could not withstand, the ship broke apart. The bow section, separated from the stern, tipped upright and began its final descent, falling more than 3,800 meters to the floor of the North Atlantic in approximately 5 minutes. The stern, suddenly freed from the weight of the bow, rose and then followed, spinning as it fell, imploding under the increasing water pressure, arriving at the bottom 600 meters from the bow section in a state of catastrophic compression. At 2:20 a.m., there was nothing left on the surface but wreckage, lifeboats, and people in the water. The water temperature was -2 degrees Celsius. At that temperature, a person who is not wearing a survival suit loses consciousness in 15 to 30 minutes and dies shortly after. The Carpathia, the closest ship to respond to the distress calls, did not arrive until 4:10 a.m. By then, most of those who had entered the water were dead. Of the 2,224 people on board the Titanic, 710 survived. The other 1,514 did not. It was the deadliest peacetime maritime disaster in history, and it remains so. The investigations that followed, one by the United States Senate, one by the British Board of Trade, produced recommendations and eventually changes. Ships were required to carry lifeboat capacity for every person on board. Ice patrol was established in the North Atlantic. Wireless operation was mandated around the clock on all large passenger ships. Bulkhead regulations were tightened. These changes were real. Many lives were saved in subsequent decades because of them. But the Titanic itself was at the bottom of the ocean, 3,800 meters down, in a location that was known only approximately, in water that was, in 1912, completely beyond human reach. The wreck did not move. The ocean did not give it back. It lay there in the dark, settling slowly into the sediment, while the world above changed beyond recognition. Empires fell, wars were fought, the century turned, the survivors aged and died. The disaster passed from news to history to myth, and the ship waited, as it would wait for decades more, in the cold and the absolute silence of the deep, unknown, unvisited, but not, as it would eventually turn out, entirely forgotten. The Titanic sank in April of 1912. The first serious attempt to locate it did not come until 1985. That is 73 years in which the wreck lay undisturbed at the bottom of the North Atlantic, in a location that was known only approximately, in water that was beyond the reach of any technology available during most of that time. 73 years is not a long time in geological terms. It is not even a long time in historical terms. But it is a long time for a mystery. Long enough for everyone who survived the sinking to age and die. Long enough for the disaster to pass from living memory into legend. And long enough for one man to become so consumed by the idea of finding it that he was willing to make a deal with the United States Navy that he has only partially spoken about in public, even decades later. His name was Robert Ballard. And the story of how he found the Titanic is not the story that most people think they know. Ballard was born in 1,942 inches, Wichita, Kansas, and grew up in San Diego, California. a child of the Pacific coast who developed an early and lasting obsession with the ocean. He studied geology and chemistry at the University of California, served in the United States Navy, and eventually joined the Woods Hole Oceanographic Institution in Massachusetts, which was and remains one of the premier ocean research institutions in the world. By the late 1970s, he had established himself as one of the leading figures in deep-sea exploration, a field that was itself still young. The technology for reaching the deep ocean with any degree of precision and mobility had only become available in the previous decade or two, and the discoveries being made were extraordinary. Ballard was part of the team that, in 1977, explored the hydrothermal vent fields at the Galapagos Rift, one of the most significant biological discoveries of the 20th century. He had seen what the deep ocean contained. He understood, better than almost anyone, what it was capable of hiding. The idea of finding the Titanic had been circulating in ocean exploration circles for years. Several expeditions had attempted it before Ballard. Between 1980 and 1983, a Texas oilman named Jack Grimm funded 3 separate search expeditions to the North Atlantic using sonar equipment to scan the seafloor in the area where the Titanic was believed to have sunk. The expeditions were logistically serious efforts, but they were hampered by imprecise knowledge of the wreck's location, by the limitations of the sonar technology available at the time, and by the sheer scale of the search area. The Titanic's distress position, broadcast by wireless operator Jack Phillips on the night of the sinking, placed the ship at 41 degrees 46 minutes north, 50 degrees 14 minutes west. But this position was calculated without GPS, without the satellite navigation that modern ships take for granted. It was an estimate based on the ship's last known position, its heading, and its speed, calculated by officers who were dealing simultaneously with a sinking ship. Later analysis suggested the position was off by several miles, and in a search area covering hundreds of square kilometers of featureless ocean floor. Several miles is the difference between finding something and finding nothing. Grimm's expeditions found nothing conclusive. The wreck remained lost. Ballard had been thinking about the Titanic for years by this point. He understood that the key to finding it was not simply better sonar, though sonar was necessary. It was a different approach to the search itself. Traditional sonar sweeps the seafloor with sound pulses and builds a picture of the bottom topography. It is good for finding large features, but can miss the scattered debris field of a wreck, especially if the search path passes between debris concentrations. Ballard's insight, developed through his work on deep-sea wreck exploration, was that a ship the size of the Titanic would not simply be sitting in one piece on the bottom. It would have broken apart. It would have scattered debris over a wide area as it sank, and as pieces fell away during the descent. That debris field might extend for hundreds of meters in the direction the wreck drifted as it sank. And a debris field of that size, covered in metal objects, would be far easier to detect with the right equipment than trying to locate the hull itself, find the debris. The hull would be at one end of it. The equipment Ballard needed to execute this strategy was a deep-towed camera sled, a platform carrying lights and cameras that could be dragged slowly across the seafloor at the end of a long cable, transmitting images back to the ship in real time. He had been developing exactly this kind of system at Woods Hole throughout the early 1980s, a system called Argo. Argo could be towed at depths of several thousand meters, maintaining a height of a few meters above the seafloor, capturing continuous video of whatever lay below. If it passed over a piece of wreckage, the image would appear on screens aboard the surface ship. The idea was to run systematic searchlines across the seafloor, covering the probable area of the wreck until something showed up. It was slow, painstaking work, but it was methodical in a way that previous searches had not been. There was, however, a problem that had nothing to do with technology. Ocean research is expensive. An expedition to search for the Titanic, requiring a research vessel, specialized equipment, a crew, and weeks of ship time in the North Atlantic, would cost millions of dollars. The scientific value of finding a passenger liner, however historically significant, was not obvious enough to attract funding from the usual sources. The National Science Foundation, which funds most American ocean research, was not going to write a check to find the Titanic. Private funding was possible, as Grimm had demonstrated, but private funders tended to come with complications. Ballard needed another way. What he found was the United States Navy, specifically the Naval Research Laboratory, and elements of the Navy's deep submergence program. The Navy had its own interest in the deep ocean that had nothing to do with ocean science and everything to do with the Cold War. In the 1960s, the United States had lost 2 nuclear submarines in the Atlantic. The USS Thresher sank in April of 1963, approximately 350 kilometers east of Cape Cod, Massachusetts, during a deep diving test. All 129 men aboard were killed. It remains the deadliest submarine disaster in American history. The USS Scorpion sank in May of 1968, approximately 740 kilometers southwest of the Azores, under circumstances that have never been fully explained. 99 men were lost. Both submarines carried nuclear weapons and nuclear reactors, and both were sitting on the floor of the Atlantic in waters several thousand meters deep. The Navy had found the wrecks using underwater acoustic techniques in the years following the sinkings. But the wrecks had not been visited, examined, or photographed in any detail. The Navy wanted to know the condition of the reactors and weapons, and whether any radioactive material was leaking into the surrounding ocean. It also, frankly, wanted to know what had happened. Ballard proposed a deal. He would use his Argo system to survey both submarine wrecks in detail, providing the Navy with the information it needed about the condition of the reactors and the state of the wrecks. In exchange, the Navy would fund the expedition, provide logistical support, and, crucially, give him whatever time remained after the submarine surveys to search for the Titanic. The Navy accepted. The arrangement was classified. When Ballard eventually sailed for the North Atlantic in the summer of 1985, the official purpose of the expedition was oceanographic research. The submarine surveys were not publicly disclosed for years. Ballard has spoken about the arrangement in interviews given decades later, but some details remain undisclosed, and the full extent of the Navy's involvement in subsequent Titanic expeditions is not entirely clear from the public record. The survey of the Thresher and the Scorpion took longer than expected. By the time Ballard's ship, the Nore, arrived in the search area for the Titanic in late August of 1985, there were only 12 days of ship time remaining before the vessel was due back in port. 12 days to search an area of seafloor covering hundreds of square kilometers using a camera sled that moved at walking pace and covered a swath of perhaps a few meters on each pass. The mathematics were not encouraging. Ballard and his team made a decision. They would not attempt a systematic grid search of the entire probable area. There was not enough time. Instead, they would focus on the area most likely to contain the debris field based on their analysis of the currents and the probable drift path of the wreck as it sank. They would run search lines across the most probable corridors and hope that the debris field was large enough and their targeting precise enough to intersect one of their passes. On the night of the 1st of September 1985, most of the scientific team had gone to sleep. The Argo sled was being monitored by a rotating watch crew, their eyes on the video screens showing the continuous feed from the cameras on the seafloor. At approximately 0 inches the morning, the seafloor on the screens, which had been showing nothing but flat mud and occasional biological activity for days, changed. Shapes appeared. Man-made shapes. A circular object. Then more pieces of metal. Then a boiler, one of the Titanic's massive steam boilers, unmistakable in its size and form, sitting alone on the ocean floor 3,800 meters below the surface. The watch crew woke Ballard. He came to the control room and looked at the screens. He knew immediately what he was looking at. The reaction in the control room was not the jubilant celebration you might expect from a team that had just made one of the greatest discoveries in the history of ocean exploration. There was celebration, but it was brief and it was complicated. Someone noted that it was nearly 0 inches the morning, September 2nd, almost exactly 73 years since the Titanic had sunk. The team gathered on the stern of the ship. Someone found a flag, the flag of the Harland and Wolff shipyard where the Titanic had been built. They stood together in the North Atlantic night, in the dark above the wreck, and observed a moment of silence. More than 1,500 people had died in that water. Whatever they had just found, it was not only a scientific discovery, it was a grave. Ballard has spoken about that moment many times since. He has said that it changed how he thought about what he had done and what he was doing. He has said that the feeling of triumph was immediately complicated by the weight of what the discovery meant. The Titanic was real. It was not a story or a legend. It was down there, and people had died on it, and their descendants were still alive, and the wreck belonged to them in some sense that had nothing to do with maritime law or oceanographic research. The Argo continued its passes over the site through the remaining days of the expedition, building up a picture of the debris field and the wreck itself. The bow section was largely intact, sitting upright on the sediment, its anchors still in their housings, its prow aimed northward. The stern was 600 meters away, separated from the bow during the final moments of the sinking, and it was in far worse condition, collapsed and compressed, the decks pancaked by the implosion as the stern had filled with air and then been crushed by the pressure of the water as it sank. Between the two sections, and extending beyond them was a debris field. Hundreds of thousands of objects, pieces of the ship, personal belongings, luggage, bottles, dishes, fixtures and fittings from the staterooms and public spaces. Everything that had been inside the ship when it sank and had been expelled as the hull broke apart. All of it lying on the mud, in the cold and the dark, exactly where it had fallen 73 years before, undisturbed, preserved by the cold and the darkness and the pressure in ways that nothing at the surface could have been. The Titanic was not just found. It was found intact, in a state of preservation that no one had expected, and that would, over the following decades, change almost everything that was known about what had happened on the night of April 14th, 1912. But finding the ship was only the beginning of what the deep ocean had to reveal. The 1985 expedition had found the Titanic. It had not visited it. Argo was a towed camera sled, not a vehicle capable of maneuvering over the wreck or descending into it. The images from 1985 were overhead views of the exterior, the debris field, the great bow section with its anchor chains still hanging. They were extraordinary images. They were not enough. Ballard returned the following year, in 1986, with a different set of tools. The centerpiece of the 1986 expedition was Alvin, the deep-diving submersible operated by Woods Hole that had been used to explore the hydrothermal vent fields at the Galapagos in 1977. Alvin could carry 3 people, a pilot and 2 scientists, to depths of 4,500 meters and maneuver over and around the seafloor with a precision that no towed system could match. Ballard also brought a smaller, remotely operated vehicle called Jason Jr., a prototype of what would become the modern ROV, a small camera platform that could be piloted through tight spaces that Alvin itself could not enter. The combination of Alvin and Jason Jr. would allow the team to descend to the wreck, examine its exterior in detail, and, if conditions allowed, send the small ROV inside through open windows and doorways. The descent to the Titanic in Alvin took approximately 2.5 hours. The submersible fell through the water column in near total darkness, its lights illuminating only the immediate vicinity, the rest of the ocean invisible around it. Then the bow of the Titanic emerged from the darkness below. Ballard, who was in the submersible on the first crew dive, has described the experience in terms that go beyond scientific observation. The bow was enormous. Even knowing the dimensions of the ship intellectually, the physical reality of it at close range was something different. It rose out of the sediment intact, its prow recognizable, its railing still in place, encrusted with the biological growth of 74 years, but fundamentally unchanged in form. The anchors were in their housings, the capstans, the large winches used to handle the anchor chains, were still on the foredeck. The ship looked, in some fundamental sense, like a ship, not a ruin, not a collection of fragments. A ship, sitting on the bottom of the ocean, waiting. Over the course of the 1986 expedition, Alvin made 11 dives to the wreck. Each dive lasted approximately 6 hours on the bottom, constrained by battery life and the physical limits of the crew. Jason Jr. was piloted through open windows and doorways into the interior of the ship, transmitting video of spaces that had been sealed since the night of the sinking. The grand staircase was gone, the wood consumed by organisms over the decades. But the staircase well was open. Jason Jr. descended it, its cameras recording cabins and corridors that no human being had seen since 1912. A porcelain sink still attached to a cabin wall, dishes stacked in a cabinet. A safe still closed. The ship was full of objects, preserved by the cold and the dark and the absence of the biological activity that would have degraded them at the surface. The effect was of a space abandoned very suddenly. Everything left exactly where it was, and then sealed away. Ballard made a decision during the 1986 expedition that he has maintained as a position ever since. He would not remove anything from the wreck. No artifacts, no samples of the hull, nothing. The Titanic was a grave, and the objects within it were part of that grave, and they should remain there. This position put him in direct conflict with subsequent expeditions that did not share it. In 1987, the year after Ballard's crude visit, a French-American consortium called RMS Titanic, Inc. mounted an expedition that recovered more than 1,800 objects from the debris field. Dishes, luggage, personal belongings, pieces of the hull, these objects were conserved and eventually displayed in traveling exhibitions that were seen by millions of people around the world. The legal and ethical questions raised by this salvage have been debated for decades and remain unresolved. Who owns the Titanic? Who has the right to decide what happens to the objects within it? These questions have no clean answers, and they are still being argued in courts and in public debate. What is not in question is that the expeditions that followed Ballard's changed the Titanic from an undisturbed grave into something more complicated, a site that has been visited, examined, sampled, and disputed, a place where the deep ocean's preservation of the past has collided with the human impulse to recover it. What the deep ocean preserved at the Titanic site is not only objects, it preserved information. The condition of the wreck, examined over multiple expeditions with increasingly sophisticated instruments, has allowed researchers to reconstruct the final minutes of the sinking in more detail than any survivor account could provide. The pattern of the break between bow and stern, analyzed by metallurgists who studied samples of the hull steel, revealed that the metal was more brittle in cold water than the specifications of the time required, a factor that contributed to how quickly and completely the ship came apart. The debris field, mapped in detail across multiple expeditions, tells its own story of those final minutes. Which objects were expelled first? Which later? What the sequence of flooding and collapse must have been? The wreck is not just a relic, it is a record. And the deep ocean kept that record intact for 73 years, waiting for someone to read it. But what the ocean was doing to the ship during those 73 years, and what it continues to do now, is a story that no one who found the Titanic was prepared for. When Ballard and his team first saw the Titanic through the cameras of Argo in 1985, and then through the viewports of Alvin in 1986, they were looking at a ship that had been on the ocean floor for 73 years. What they saw was not what anyone had expected. The hull was intact, The bow was recognizable. Objects from the interior were lying on the sediment in the debris field, preserved well enough to be identified at a glance. By any reasonable comparison to a wreck of similar age sitting in shallower water, the Titanic was extraordinarily well preserved. The cold, the darkness, and the pressure of 3,800 meters had done what no museum conservator could have managed. They had slowed the processes of decay almost to a halt. Almost, but not entirely. And what the ocean was doing to the Titanic, slowly and invisibly and without any possibility of intervention, turned out to be one of the most remarkable biological and chemical stories in the history of wreck exploration. The first thing that the expedition scientists noticed, looking at the hull in detail, was the presence of formations they had never seen before. Long rust-colored stalactites hanging from the steel, sometimes reaching lengths of a meter or more, trailing from railings and hull plates and structural members wherever the steel was exposed. They looked organic. They looked almost alive. They were given a name almost immediately: rusticles, a portmanteau of rust and icicles, coined by Ballard's team during the 1986 expedition. The name stuck. But what rusticles actually were took years of subsequent research to fully understand, and what they revealed about the fate of the Titanic was more unsettling than anyone who found the wreck had anticipated. Rusticles are not simply rust. They are not the ordinary oxidation of iron that produces the reddish-brown flaking you see on an old bridge or a neglected car. They are biological structures. Living communities of microorganisms, primarily bacteria, that have colonized the steel of the Titanic's hull and are very slowly consuming it. The bacteria involved are iron-oxidizing and iron-reducing species. Organisms that use iron compounds as an energy source, cycling the metal through chemical reactions that produce the characteristic rusty formations as a byproduct. The rusticles are, in effect, the physical residue of bacterial metabolism. They are what is left behind as the bacteria extract energy from the steel. The microbial community inside a rusticle is complex. Researchers who have collected samples and analyzed them have found dozens of distinct bacterial species living together in a structured community, each occupying a different position within the formation and performing a different chemical function. The outer surface of a rusticle is dominated by iron-oxidizing bacteria that interact with the oxygenated seawater flowing past. The interior contains anaerobic bacteria, species that cannot tolerate oxygen, living in the low-oxygen environment created by the activity of the outer layers. The whole structure is a miniature ecosystem, organized around the chemical gradients created by the bacteria's own metabolic activity. It is a community that has assembled itself over decades, species by species, each finding its niche in the structure created by the others. The rusticles are fragile. When the ROV Jason Jr. brushed against them during the 1986 expedition, they crumbled into clouds of reddish particles and dissolved into the water. This fragility is part of what makes them so consequential. They're not simply sitting on the surface of the steel, like rust on a bridge. They are consuming the steel from within, their bacterial communities penetrating the metal, extracting iron from the crystal structure of the steel itself. When a rusticle falls, as it eventually does when it grows too heavy or is disturbed, It takes a portion of the original hull material with it. The steel beneath is thinner than it was. The hull is being eaten. How fast? This is the question that oceanographers and conservation scientists have been trying to answer since rusticles were first identified. The answer depends on which part of the hull you are measuring, what the local conditions are, and what assumptions you make about the rate of bacterial metabolism at the temperatures and pressures of the wreck site. But the estimates that have emerged from decades of study are sobering. Some researchers who have compared images of the Titanic taken in 1986 with images taken in subsequent expeditions in the 1990s and the 2000s, and most recently in 2010 and 2019, have concluded that the rate of deterioration is accelerating. Areas of the hull that appeared structurally sound in 1986 had collapsed by 2010. The officers' quarters, the area aft of the bridge on the boat deck, had essentially disappeared by the time of the 2019 expedition, conducted by Atlantic Productions in partnership with Ocean Gate Expeditions, using the most advanced imaging technology yet applied to the wreck. An entire section of the hull that had still been standing as a recognizable structure in earlier visits had pancaked downward, the deck plates collapsing onto each other as the internal steel framework was consumed. The 2019 expedition produced something that previous visits had not: a complete photogrammetric scan of the wreck, combining thousands of individual images into a three-dimensional model of the entire site with a resolution precise enough to identify individual rivets. This model exists now as a permanent record of the Titanic's condition at that moment. It will serve as a baseline against which the deterioration visible in future expeditions can be measured. The researchers involved in the 2019 survey were direct about what they found. The wreck is collapsing. The rate of collapse is not uniform, varying significantly between different sections of the ship, but the overall trajectory is clear. The Titanic that exists today is not the Titanic that Ballard found in 1985. And the Titanic that will exist in 50 years will not be the Titanic that exists today. The bacteria are not the only agents at work. The hull steel of the Titanic is also subject to straightforward chemical corrosion. The reaction between iron and seawater that produces iron hydroxides and other compounds, weakening the metal regardless of any biological activity. The specific steel alloy used in the Titanic's construction, typical of the early 20th century, is more susceptible to corrosion in cold, oxygenated seawater than modern high-strength steel alloys. The water at 3,800 meters depth in the North Atlantic is cold and, despite being far from the oxygenated surface, still contains enough dissolved oxygen to drive corrosion reactions. The pressure at that depth does not significantly slow chemical corrosion and may accelerate some reactions by forcing water and dissolved gases into cracks and pores in the metal. The wood is almost entirely gone. This is one of the most striking aspects of the wreck for anyone who has studied photographs of the Titanic's interior before it sank. The grand staircase, made of polished oak with ornate carved details, no longer exists. The teak decking that covered the promenades and boat deck has been consumed. The wooden paneling of the first-class cabins and public rooms is gone. What destroyed the wood was not bacteria, but a different class of organism entirely: wood-boring mollusks of the genus Teredo, commonly known as shipworms. Shipworms are not worms at all. They are bivalve mollusks, relatives of clams and oysters, with a small shell modified into a drilling apparatus at one end of an elongated body. They bore into submerged wood and consume it, extracting nutrition from the cellulose with the help of symbiotic bacteria. Teredo species have been the bane of wooden ships since the first vessels were launched, and they are present throughout much of the world's oceans. Whether they are active at the depth of the Titanic is debated, and bacterial degradation of the wood may account for much of the loss. But the result is not in question. The teak decking, the oak paneling, the wooden partitions that divided the cabins, the joists beneath the floors, all of it is gone. Where there was structure, there is now absence. What the disappearance of the wood means structurally is significant. Much of the Titanic's interior structure depended on wooden elements, not merely for decoration, but for support. Cabins were divided by wooden partitions. Floors were laid on wooden joists. When the wood is gone, the metal framing that surrounded it loses its support and eventually collapses. This is why the officers' quarters and other sections of the ship that contained large amounts of wood have deteriorated faster than the bare steel sections of the hull. The wood was not just an aesthetic element. It was structural, and its loss has been one of the primary drivers of the collapse observed in recent decades. What is preserved, and what is being preserved rather than destroyed, is one of the stranger aspects of the Titanic's condition. Personal objects made of metal, glass, and ceramic have survived with remarkable fidelity. The porcelain dishes in the debris field are intact, their patterns still visible, their glazed surfaces undamaged by a century on the seafloor. Silver serving pieces are tarnished but recognizable. Copper and brass fittings from the engine room are covered in patina but structurally sound. Glass bottles are unbroken. A leather shoe, recovered from the debris field, retained its shape well enough to be displayed in a museum exhibition, though the biological material of the leather had been altered by the deep-sea environment. The selective preservation of the Titanic's debris field is itself a kind of record. What survives tells you something about the chemistry of the deep ocean. What does not tells you something about what the deep ocean is capable of consuming. The human remains are gone. This is a fact that is sometimes discussed carefully and sometimes avoided entirely in accounts of the wreck, but it is a fact worth facing directly. In the immediate aftermath of the sinking, more than 1,500 people died in the water or went down with the ship. Some bodies were recovered in the days following the disaster by ships sent to the site, but the majority were never recovered. They are at the bottom of the North Atlantic. The question of whether any remains might have been preserved at the wreck site was one that researchers approached with sensitivity. The answer, established through careful examination of the debris field and the interior of the wreck, is that no skeletal remains have been found. The organic matter of the human body, bone included, does not survive at 3,800 meters depth in the North Atlantic over the course of a century. The cold and the pressure slow decomposition but do not stop it. The bacteria, the same communities that are consuming the steel, have processed everything organic. The people who died on the Titanic are gone in every physical sense. What remains is what they left behind. The shoes, the luggage, the personal effects scattered across the debris field, and the ship itself fading slowly in the dark. There is one object in the debris field that has drawn more attention than almost any other, not because of its monetary value or its historical significance in a conventional sense, but because of what it represents. It is a pair of shoes, 2 leather shoes, sitting upright on the sediment, approximately half a meter apart, oriented as if a person were still wearing them and standing on the ocean floor. They are not connected by any visible remains. The person they belong to is entirely gone. But the shoes held their shape, their laces still threaded through the eyelets, their soles still intact, and they sit in the mud in a posture that is unmistakably human. They have been photographed on multiple expeditions. They appear in documentaries and in scientific papers. They are, for many people who study the Titanic, the single most affecting image the wreck has produced. Not the grand bow rising from the sediment, not the staircase well descending through the decks. 2 shoes on the mud, in the dark, holding the shape of someone who is no longer there. The deterioration of the Titanic raises questions that have no comfortable answers. The wreck is not legally protected in the way that a terrestrial archaeological site would be. It lies in international waters, beyond the jurisdiction of any single nation, and the legal framework governing access to it is a patchwork of international agreements, court rulings, and voluntary guidelines that different parties have interpreted in different ways. The United States passed the RMS Titanic Maritime Memorial Act in 1986, the same year as Ballard's crewed expedition, which directed the government to work toward an international agreement to protect the wreck as a memorial. A UNESCO Convention on the Protection of Underwater Cultural Heritage, adopted in 2001, established guidelines for the treatment of wrecks more than 100 years old. But neither of these frameworks has prevented the ongoing salvage operations conducted by RMS Titanic Inc., which holds exclusive salvage rights under a United States federal court ruling from the 1990s, and has recovered thousands of artifacts from the debris field over the course of multiple expeditions. The artifacts recovered from the Titanic have been seen by millions of people in traveling exhibitions on multiple continents. The question of whether their recovery was justified, whether removing objects from an underwater grave for display in a museum is ethically defensible, is one that different people answer differently, and neither answer is obviously wrong. What is clear is that the recovered objects tell stories that are not told by photographs alone. A pocket watch, its hands stopped at a few minutes after 2. A child's toy. A first-class menu, the paper somehow preserved by the cold and the anoxic conditions in a particular section of the debris field, its courses still legible. A leather bag with its contents intact. These objects connect the disaster to individual human lives in ways that aggregate statistics cannot. They are also, by virtue of their removal from the site, things that future researchers and future technology will never be able to study in their original context. That context, the precise position of each object in the debris field, what it lay next to, what it lay beneath, is information that cannot be recovered once an object is lifted. Every artifact removed from the Titanic is also an irreversible act. What remains at the site, the wreck itself, and the objects still in the debris field will continue to change. The rusticle communities will continue their slow consumption of the hull. The rate may increase as the ocean warms and as the oxygen content of deep water changes in response to shifting surface conditions. Or it may slow if the bacterial communities exhaust the most accessible iron in the hull surface and are forced to work deeper into the metal at a slower pace. The models for predicting the wreck's future condition are imprecise because the biological and chemical processes involved are complex and because they have never been studied in anything comparable to the Titanic before. What all the researchers who have studied the wreck agree on is the direction of travel. The Titanic is disappearing. The bow that rose so impressively from the sediment will collapse. Section by section, deck by deck. The rusting steel frames that still hold the shape of staterooms and corridors will buckle under their own weight as the iron is consumed. The great anchors, still in their housings when Ballard first saw them, will eventually separate from the hull as the metal surrounding them fails. The debris field will outlast the ship itself. The ceramic dishes and the glass bottles and the brass fittings, the things the ocean cannot consume, will remain long after the hull that launched them from Belfast is gone. They will lie on the sediment in the cold and the dark, without any structure around them to indicate what they once were part of, without any context for someone arriving at the site 1,000 years from now to make sense of. There is something almost unbearable about this, and something in equal measure entirely natural. The Titanic is iron and carbon and hydrogen and oxygen, the same elements as everything else, returned slowly to the chemistry that has always governed them. The ocean is not destroying something sacred. It is simply doing what it has always done, cycling the materials of the world through its enormous, patient processes. The ship is temporary. Everything is temporary. The ocean makes that plain. What the ocean cannot tell you, and what the wreck cannot answer, is whether it was worth going down there to look. Whether the knowledge gained, the images captured, the artifacts recovered, the stories told and retold, justified the intrusion into a place that had been, for 73 years, undisturbed. That question has been answered, in practice, by the number of expeditions that have followed Ballard's. Dozens of them, each one pushing deeper into the wreck and the debris field, each one producing new information and new images, and, in some cases, new controversies. The Titanic has been visited more in the 4 decades since its discovery than most places on Earth, and every one of those visits has left its mark, not just in the scientific record, but on the wreck itself. Because descending to 3,800 meters in a vehicle capable of maneuvering over and around a fragile, deteriorating structure is not a neutral act. The ROV thrusters stir the sediment. The submersible's hull brushes against structures, rusticles fall. And in June of 2023, the cost of going to the Titanic became impossible to ignore. In the decades after Ballard's expeditions, the Titanic became something it had never been during the years when it was simply lost, a destination. Not for scientists only, not for salvage operators only, but eventually for paying passengers. The idea that ordinary people with no scientific training and no operational role, could descend 3,800 meters to the ocean floor simply because they wanted to see the Titanic, and could afford to pay for the privilege, emerged gradually and became, by the early 2020s, a commercial reality. It was also, as it turned out, a preview of what the deep ocean does to the unprepared. The first tourists to visit the Titanic did so in the early 1990s, aboard Russian Mir submersibles operated by the Shirshov Institute of Oceanography. The Mir vehicles were capable research submersibles, well built and well operated, and the dives they conducted were genuinely serious in a technical sense. But the passengers paying for berths on those dives were not researchers. They were wealthy individuals who wanted an experience that very few people in human history had ever had. The price for a berth on a Titanic dive in that era ran to tens of thousands of dollars. The number of people who made the journey was small, but not trivial. Dozens of private individuals descended to the wreck over the course of those expeditions. Director James Cameron made his first dive to the Titanic aboard a Mir submersible in 1995, before his film was released, and returned many times afterward, eventually logging more dives to the wreck than almost anyone alive. The Titanic was becoming, in addition to everything else it was, a tourist attraction at the bottom of the ocean. The trajectory of this development led, by the late 2010s, to a company called OceanGate. OceanGate was founded in 2009 by Stockton Rush, an entrepreneur with a background in aerospace and a stated ambition to democratize access to the deep ocean. The company's business model was to build submersibles capable of reaching extreme depths and use them for scientific research, and, alongside the science, for paying expeditions that would fund the operation. Rush had a particular philosophy about deep-sea vehicle design that would become, in retrospect, central to everything that followed. He believed that the conventional approach to building deep-sea pressure vessels, using titanium or thick steel spheres, tested exhaustively against established engineering standards, was unnecessarily conservative and unnecessarily expensive. He believed that carbon fiber, a material widely used in aerospace applications for its combination of high strength and low weight, could be used to build a pressure vessel that would be lighter, cheaper, and adequately strong for deep-sea operations. The engineering establishment disagreed. Carbon fiber behaves very differently under compressive loading than it does under tensile loading. Pressure vessels at depth experience compressive loading, the pressure of the ocean pushing inward from all directions, and carbon fiber under cyclic compressive loading, the repeated pressurization and depressurization that occurs every time a submersible dives and surfaces, degrades in ways that are difficult to detect visually and difficult to predict precisely. The concern was not theoretical. It was grounded in decades of materials science research. Rush dismissed these concerns. He described the established standards for submersible construction, maintained by classification societies like the American Bureau of Shipping, as an obstacle to innovation rather than a necessary safeguard. OceanGate did not submit its primary deep diving vehicle, the Titan, to classification by any recognized standards body. The Titan was a submersible, approximately 6.7 meters long, built around a pressure hull consisting of a carbon fiber cylinder with titanium end caps. It was designed to carry 5 people to depths of 4,000 meters, sufficient to reach the Titanic. OceanGate began taking paying passengers to the Titanic in 2021 charging approximately $250,000 per person for a berth on a dive. The dives were marketed as expedition experiences, with passengers framed not as tourists but as mission specialists contributing to genuine scientific work. Some scientific work was indeed conducted on the expeditions, but the primary commercial draw was the Titanic itself, and the primary product being sold was the experience of descending to it. The warnings had been accumulating for years before the end came. Former OceanGate employees had raised concerns internally about the safety of the Titan's carbon fiber hull. A senior director of marine operations at the company had submitted a letter in 2018 expressing concern that the vehicle had not been classed by a recognized standards organization and urging that it be tested against established safety standards. He was dismissed shortly afterward and subsequently filed a wrongful termination lawsuit, which was settled. The lawsuit and the underlying concerns were a matter of public record. The Marine Technology Society, a professional organization for ocean engineering professionals, wrote a letter to OceanGate in 2018, signed by dozens of industry experts expressing concern about the company's approach to safety certification and urging it to pursue classification through an established standards body. OceanGate did not change its approach. On the 18th of June, 2023, the Titan departed the surface of the North Atlantic on a dive to the Titanic. On board were Stockton Rush, the company's founder and CEO, who piloted the vehicle himself; Hamish Harding, a British businessman and aviator who held multiple world records for extreme exploration; Paul-Henri Nargeolet, a French deep-sea explorer and former French Navy officer who had made more dives to the Titanic than almost anyone in the world, and who served as the expedition's Titanic expert; Shahzada Dawood, a Pakistani-British businessman; and Shahzada's son, Suleiman Dawood, who was 19 years old. The surface support ship was the Polar Prince, operated by a Canadian company. The Titan began its descent at approximately 80 inches the morning local time. Contact with the surface was lost approximately 1 hour and 45 minutes into the dive. The Polar Prince attempted to re-establish contact. It could not. What followed was one of the most intensely covered search and rescue operations in recent memory. The United States Coast Guard coordinated the response. Ships and aircraft from multiple nations converged on the search area. The coverage was extraordinary, and it was, in retrospect, covering an event that had already ended. The acoustic data that would later confirm what had happened was already in the hands of the United States Navy by the time the public search began. The Navy's underwater hydrophone network, designed to detect submarine activity, had recorded an anomalous acoustic event in the area of the Titanic dive at approximately the time contact was lost. The event was consistent with an implosion. The Navy assessed this information and passed it to the Coast Guard, but the search continued publicly for days as the authorities worked through the uncertainty and as hope, however diminishing, was maintained for the benefit of the families. On the 22nd of June, 2023, debris from the Titan was found on the ocean floor several hundred meters from the bow of the Titanic. The debris was consistent with a catastrophic implosion of the pressure hull. The 5 people aboard had died instantaneously, at the moment of implosion at a depth of approximately 3,500 meters. Death at that depth from an implosion of that kind is not slow. The pressure differential between the interior of the vessel and the surrounding ocean at that depth is approximately 350 atmospheres. When a pressure vessel fails at that depth, the failure is not a leak or a crack that develops gradually. It is a total structural collapse that occurs in a fraction of a millisecond. The people inside are gone before any signal from the nervous system could reach the brain. The ocean does not give warnings. The investigation that followed examined the wreckage and the design history of the Titan. What it found was consistent with what the critics had said for years. The carbon fiber hull had experienced cyclic fatigue, the progressive degradation of the material under repeated compressive loading that materials scientists had warned about. Each dive had stressed the hull in ways that were not visible externally and were not being tracked by any monitoring system capable of detecting the cumulative damage. The hull had been rated for a certain number of dives, but the rating was based on OceanGate's own testing, not on independent verification against established standards. The exact number of dives the Titan had made before it failed, and the precise relationship between that number and the failure became part of the investigation. What was clear was that the outcome was not unforeseeable. The people who had warned about it had foreseen it. Their warnings had been ignored. Paul-Henri Nargeolet had more experience with the Titanic than perhaps anyone else who has ever dived to it. He had been part of the RMS Titanic Incorporated salvage expeditions that began in 1987. He had dived to the wreck dozens of times over more than 3 decades. He had spent more cumulative hours at 3,800 meters in the vicinity of that particular wreck than almost any person alive. He knew the deep ocean. He knew what it demanded. He chose to go on the Titan's expedition, and whatever his private assessment of the risk may have been, he made that choice as an adult with more relevant knowledge than almost anyone. That does not resolve the ethical questions about what OceanGate built and how it operated. It simply adds another layer to a story that does not have clean edges. Suleiman Dawood was 19. His father had booked the expedition as a gift, something extraordinary, a journey to one of the most famous places on Earth, an experience that almost no one in history had ever had. Suleiman had reportedly expressed reservations about going. He went anyway because his father was going, and because 19 is an age at which you do things for reasons that are not entirely your own. He is buried now at 3,500 meters in the North Atlantic, not far from the Titanic, not far from the more than 1,500 people who died in those same waters in April of 1912. The ocean that took them in 1912 is the same ocean. It does not distinguish between the victims of catastrophic negligence and the victims of catastrophic design failure. It is simply the ocean, cold and dark and entirely indifferent to the intentions of the people who enter it. The wreckage of the Titan sits on the seafloor. It will be there for a long time. The ocean will do to it what it is doing to the Titanic, slowly and without haste. The carbon fiber will degrade differently than steel, but it will degrade. The titanium end caps will corrode more slowly. Eventually, over time measured in decades or centuries, the debris will become part of the sediment, and the sediment will record it the way it records everything, patiently and without comment. 100 years from now, if someone descends to that part of the North Atlantic, they will find the Titanic still there, reduced further by the bacteria and the chemistry of the deep, and somewhere nearby, among the rocks and the mud, the last traces of the Titan. 2 vessels, 2 catastrophes, 1 ocean, utterly unchanged. The Titan disaster did something to the public conversation about deep-sea exploration that years of scientific argument had not managed to do. It made the costs concrete. Until June of 2023, the deep ocean was, for most people, an abstraction, a place in documentaries, a subject of scientific papers, a backdrop for the Titanic story. After June of 2023, it was a place where 5 people had just died in a vehicle that its own manufacturer had been warned was not safe, going to see a wreck where 1,500 people had died before them. The layers of the story compressed into a single point. The hubris of the Titanic's builders. The hubris of OceanGate's founder. The ocean that ended both of them in the same patch of water, more than a century apart, with the same indifference. Stockton Rush had said, in an interview conducted before the disaster, that he had broken some rules with the Titan's design, rules he believed were unnecessary. He said that he wanted to be remembered as an innovator. He was not wrong that the established rules of deep-sea vehicle design are conservative. They are conservative for reasons that the history of the deep ocean makes clear. The ocean does not forgive partial compliance. It does not grade on a curve. The engineering margins that classification societies require are not arbitrary bureaucratic obstacles. They are the crystallized memory of every failure, every incident, every close call that has occurred in decades of deep-sea operations. They exist because the consequences of being wrong at 3,500 meters are not recoverable. Rush knew the deep ocean, or believed he did. What he appears not to have fully internalized is that knowing the deep ocean and respecting it are not the same thing. The Titanic's builders knew the North Atlantic. They did not respect it enough. There is a pattern here that is not coincidental. The Titanic sank because its designers were confident that they had engineered away the risk. OceanGate's Titan imploded because its designer was confident that he had identified which rules mattered and which did not. In both cases, the confidence was genuine. In both cases, the ocean disagreed. The deep ocean does not care about confidence. It does not respond to ambition or innovation or the desire to be first. It responds only to physics, and physics is not negotiable. The pressure at 3,500 meters is what it is. The compressive fatigue behavior of carbon fiber under cyclic loading is what it is. These are not parameters that change because someone has a vision. They are constants. And failing to take them seriously in either 1912 or 2023 produces the same result. What the Titan disaster changed, practically, is the regulatory landscape for deep-sea tourism. Before June of 2023, there was no binding international framework specifically governing commercial passenger submersibles operating in international waters. Classification by recognized standards bodies was voluntary. After June of 2023, that position became politically untenable. The United States Coast Guard, which has jurisdiction over vessels operating from American ports and over American-flagged vessels, moved to tighten oversight of submersible operations. International discussions about a binding framework for deep-sea passenger vehicles accelerated. Whether those discussions will produce effective regulation is not yet clear. The deep ocean is a regulatory frontier in ways that commercial aviation and maritime shipping are not, and the political will to close those gaps tends to emerge only after disasters of sufficient visibility. The Titan provided that visibility. Whether it will be enough remains to be seen. There is something else the Titan disaster revealed, something quieter and more personal than the regulatory questions. It revealed how powerful the Titanic's pull remains, more than a century after the sinking, more than 4 decades after the wreck was found. 5 people paid, or were paid, to go to the bottom of the ocean to see it. Dozens of people before them had done the same. Hundreds more were on waiting lists. The Titanic is not simply a historical event. It is not simply a famous shipwreck. It is something closer to a pilgrimage site, a place that people feel compelled to visit in person, even when the risks of doing so are not trivial, even when the intellectual knowledge gained could be obtained more safely by watching documentary footage from an armchair. There is something about being physically present in a place, about the knowledge that you are there, that the wreck is outside the window rather than on a screen, that draws people into decisions they might not otherwise make. This is a very human impulse. It is the same impulse that drives people to climb mountains that could kill them, to cross oceans in small boats, to enter environments that are not built for human beings. The desire to be there, to have been there, to know in your body as well as your mind what a place is. The deep ocean is perhaps the ultimate expression of this impulse because it is so thoroughly inhospitable to human beings in the physical sense. You cannot breathe there. You cannot survive the pressure. You cannot exist there without the protection of an engineered vehicle that stands between you and the ocean. And yet people go. They will keep going. The Titan disaster will not end deep-sea tourism. It will change it, regulate it, make it more expensive and more carefully overseen. But it will not end the impulse that drives it. The ocean is too compelling, and the wreck is too famous, and the human desire to be where things happened is too deep. The Titanic sits at the intersection of all of this. It is a ship, it is a grave, it is a scientific site, it is a legal dispute, it is a regulatory lesson. It is a mirror in which we see our own tendencies toward overconfidence and our own longing to be present at places of significance. And it is doing all of this while slowly, imperceptibly, molecule by molecule, returning to the chemistry of the sea that holds it. The bacteria do not know what the Titanic is. They know iron. They process iron. And the iron in the Titanic's hull is, to them, the same as any other iron. But what that iron and the ship it was shaped into, and the people who built it and sailed it and died on it, tell us about ourselves is something that the bacteria cannot answer. That answer requires looking not at the wreck, but at what the wreck has come to mean. And that is a question with a longer history than most people realize. The Titanic has been part of the public imagination for so long that it is easy to forget how strange its persistence actually is. Most disasters of comparable scale do not achieve this kind of cultural endurance. Ships have sunk with greater loss of life. Wars have killed in numbers that make 1,514 seem small. Industrial accidents, famines, epidemics have come and gone without leaving anything like the mark that the Titanic has left. And yet here we are, more than a century later, and the name still means something to almost everyone who hears it, not just as a historical reference, as a feeling. The Titanic does not merely describe an event, it describes a category of human experience. The category of things that were supposed to be safe and were not. The category of confidence that turned out to be misplaced. The category of the last night before everything changed. Why this ship? Why this disaster out of all the disasters that history has produced? The answers are not simple, and they are not all flattering to the people who have kept the story alive. Part of it is the scale of the original event itself. Part of it is the passenger list, the presence of famous wealthy people whose names were already known to newspaper readers in 1912, which guaranteed extensive coverage and gave the disaster a human face that a ship carrying unknown emigrants would not have had. Part of it is the specific cruelty of the circumstances, the lifeboats that left half empty, the class disparities in survival rates, the orchestra playing on the deck. These details have a narrative coherence that feels almost designed, though of course it was not designed at all. It is simply what happened, and what happened was vivid and unjust and human in ways that made it impossible to look away from then and impossible to entirely look away from now. But there is something else, something deeper than the specific details of the disaster that has kept the Titanic in the cultural conversation for 113 years. It is the timing. The Titanic sank in April of 1912, at a particular moment in history that was itself poised on the edge of catastrophe. 2 years later, the First World War would begin, and the world that built the Titanic, the world of empires and ocean liners, and the certainty of progress, would be destroyed as thoroughly as the ship itself. The Titanic was, in retrospect, the last great act of a civilization that was about to end. The confidence it embodied, the belief that human engineering had tamed the natural world, that the machinery of industrial capitalism would carry humanity forward indefinitely without serious interruption, was a confidence that the 20th century would spend the next several decades systematically destroying. The Titanic sank in the last moment before the world understood what the 20th century was actually going to be. And because of that timing, it has functioned ever since as a kind of marker. Before. The world before. The story has been told so many times, in so many forms, that the telling itself has become part of what the Titanic is. Within weeks of the sinking, survivors were giving paid lectures. Within months, the first films were being made. The silent film actress Dorothy Gibson, who had survived the disaster herself, starred in a one-reel film called Saved from the Titanic, released just 29 days after the sinking, while Gibson was still reportedly suffering from shock. The film is lost. Most silent films are. But its existence tells you something about the speed with which the disaster became a story that people wanted to consume, and about the willingness of those who had lived through it to participate in the consumption. The Titanic entered the cultural bloodstream almost immediately and has never left it. The books came next, and they have never stopped coming. Walter Lord's A Night to Remember, published in 1955, was the first serious popular history of the disaster based on interviews with survivors, and it gave the story a narrative shape that influenced almost everything that followed. Lord interviewed survivors who were still alive in the early 1950s, people who had been children or young adults on the night of the sinking, and he captured details of the experience that would have been lost had he waited another decade. His book was adapted into a British film in 1958. That film shaped the visual imagination of the disaster for a generation. And then, nearly 40 years later, James Cameron's film arrived. Cameron's Titanic, released in December of 1997, was at the time the most expensive film ever made, with a production budget of approximately $200 million. It was also, when it opened, one of the most commercially successful films ever made, eventually grossing more than $2 billion worldwide and winning 11 Academy Awards, including Best Picture. It introduced the story to a generation that had not grown up with Walter Lord's book or the 1958 film, and it did so with a visual fidelity to the ship itself, built from Ballard's footage and from detailed historical research that no previous depiction had achieved. The grand staircase, the engine rooms, the promenade decks, the lifeboats, the sinking itself, all of it rendered in a detail that felt, to audiences who had never seen the wreck, like the experience of being there. Cameron had dived to the Titanic himself multiple times, and the intimacy with the actual wreck shows in the film. He knew what the real ship looked like, and he built it. The film also fixed certain images of the disaster in the public imagination so firmly that they are now inseparable from the event itself, regardless of their historical accuracy. The fictional love story at its center is not history. The depiction of specific characters behaving in specific ways in the final hours is dramatization. Some of it well grounded in survivor testimony, some of it invented. First Officer Murdoch, depicted in the film as shooting a passenger and then himself in the final chaos on deck, was a characterization that outraged Murdoch's surviving relatives and prompted Cameron to issue a personal apology to the town in Scotland where Murdoch had grown up. The film's Titanic is not the historical Titanic exactly. It is a version of the Titanic, shaped by narrative necessity and cinematic convention, but it is the version that most people alive today carry in their minds when they hear the name. The gap between the film's Titanic and the historical Titanic is itself a kind of artifact, evidence of how thoroughly the disaster has been processed through the machinery of storytelling. What has a century of retelling done to our understanding of what actually happened? In some ways, it has deepened it. The scholarly literature on the Titanic is extensive. running to hundreds of serious books and thousands of academic papers covering the engineering, the social history, the meteorology, the oceanography, the legal aftermath. The disaster has been examined from almost every possible angle. The metallurgical analysis of the hull steel, the social demographics of who survived and who did not, the wireless communications in the hours before and after the sinking, the biographies of the key figures, the subsequent careers of the survivors, the history of the search, the biology of the wreck site. There are people who have spent entire careers studying the Titanic, and the body of knowledge they have produced is substantial and serious. The disaster is, in this sense, among the best documented single events in modern history. In other ways, the century of retelling has obscured things. The fictional versions, accumulated over decades, have contaminated the historical record in the public mind. Details that come from films are remembered as facts. Scenes that were invented are recalled as eyewitness accounts. The orchestra playing on the deck is historical, supported by multiple survivor testimonies. The specific piece of music they played last is not established, despite decades of confident assertion in various popular accounts. The story has been told so often that the telling has become indistinguishable for most people from the event itself. This is what happens to famous disasters over long periods of time. They become myths in the technical sense of the word, stories that carry meaning beyond their historical content, stories that a culture uses to think about itself. What the Titanic myth carries, at its core, is the question of hubris. The word comes from ancient Greek, and it referred originally to a specific kind of offense, the arrogance of a human being who acts as though the god's authority does not apply to them, who reaches beyond the limits that existence imposes and is destroyed by the reaching. The Greeks used the concept to explain tragedy. The Titanic fits the template almost perfectly. A ship that its builders called unsinkable. A crossing attempted at speed through waters known to contain ice. A disaster that killed the richest people in the world alongside the poorest, indifferent to wealth and status and social position. An ocean that did not receive the message that it had been conquered. The story has the structure of a Greek tragedy because the event itself had that structure. The disaster was not random. It followed from specific decisions made by specific people who believed that their engineering and their confidence placed them beyond the reach of ordinary consequence. It did not. And this is why the Titanic still matters. Beyond the historical significance, beyond the engineering lessons, beyond the grief of those who lost family members and the still accumulating scholarly literature. It matters because the question it asks, whether human confidence in technology and systems and engineering can actually protect us from the indifference of the physical world, is a question that has not been answered in the years since 1912. If anything, it has become more urgent. We have built systems of greater and greater complexity, each one representing a claim that we understand our environment well enough to manage it reliably. Some of those claims are justified. Many are. The systems work, most of the time, through the careful application of exactly the kind of engineering margins and safety standards that the Titanic's builders did not apply and that OceanGate's founder dismissed. But the ocean is still there. The ice is still there, and the confidence is still there. It has never gone away. It simply finds new expressions, new vehicles, new arguments for why this time the engineering is sufficient, why this time the margins can be reduced, why this time the rules that protected us before are unnecessary obstacles to progress. The Titanic is 3,800 meters below the surface of the North Atlantic. It has been there for 113 years. The bacteria are eating it slowly, and in the decades to come, the structure will continue to collapse section by section until what Ballard found in 1985 is no longer recognizable as a ship. The debris field will remain longer, the ceramic and the glass and the brass lying in the cold mud in the absolute dark, slowly being covered by the settling sediment of a century, and then another century, and then another. The shoes will be there in the dark for a very long time, and the ocean will be there, as it has always been, patient and cold and indifferent, neither cruel nor kind, simply present, holding everything that has ever been given to it with the same quiet permanence. The Titanic is part of the ocean now. It was always going to be. The ocean was always going to win. That is not a tragedy. It is just the nature of the place we live, a planet whose surface is mostly water, whose depths are mostly unknown, and whose indifference to human ambition is one of the few constants we can rely on. The wreck is down there tonight, in the dark, in the cold, patient as the ocean itself. And if you let yourself drift toward sleep now, let the weight of the day settle slowly downward, like marine snow falling through 3,800 meters of dark water. You are moving in the same direction as everything eventually moves, toward the deep, toward the quiet, toward the vast, unhurried patience of the ocean floor. There is a particular kind of knowledge that comes from understanding something not just intellectually, but historically. Knowing the facts about the Titanic is one thing. Knowing what it meant to the people who lived through its sinking and to the people who grew up in its shadow is another. The survivors of the disaster carried it with them for the rest of their lives in ways that were not always visible. Milvina Dean, the last surviving passenger from the Titanic, died in 2009 at the age of 97. She had been 2 months old when the ship sank. She had no conscious memory of the event, and yet it defined her life in ways she did not choose. She was the Titanic baby. She was photographed throughout her life in connection with the disaster. She gave interviews. She attended memorials. She sold personal mementos late in life to pay for nursing home fees. Her connection to the event, which she had experienced only as an infant, was the defining fact of her public identity for nearly a century. She did not choose the Titanic. The Titanic chose her. And when she died, the last living link between the present and the night of the 14th of April 1912 was severed. The disaster passed entirely into history, with no one left who had been there. What happens to a disaster when the last survivor dies? It does not become less real. The facts do not change. The wreck is still on the ocean floor. The descendants of those who died are still alive, and some of them have spent their adult lives researching and commemorating an event they know only through family stories and historical documents. But something does change. The testimony of direct experience is gone. The disaster becomes fully and finally a matter of record rather than memory. The gap between 1912 and the present becomes unbridgeable in a particular way. There is no one left to ask what it was like. There is only what was written down, what was filmed, what was preserved, and what the wreck itself still holds in the cold and the dark. The ocean has become the last witness. This is true of many historical events, of course. It is the nature of time. What makes the Titanic unusual is the degree to which the physical evidence, the wreck, has survived. Most historical events leave only documents. The Titanic left a ship, a deteriorating, collapsing, slowly vanishing ship, but a ship nonetheless, sitting on the ocean floor with objects still inside it that the people who died carried onto the vessel in Southampton in April of 1912. A pocket watch that belonged to someone. A suitcase packed by someone who expected to unpack it in New York. A pair of shoes worn by someone who had no reason to imagine they would still be on the ocean floor 100 years later. These objects are not abstract. They are not representations of the disaster. They are the disaster in physical form, preserved by the deep ocean in a way that nothing on the surface could have managed. And they will continue to be preserved in diminishing form for decades to come. The scientific value of the Titanic as a research site has evolved considerably since Ballard's first expeditions. In the 1980s and 1990s, the primary scientific interest was in the wreck itself, its condition, its biology, the rusticles, and the organisms that had colonized it. In subsequent decades, the interest has expanded. The Titanic site is now studied as a model for understanding how deep-sea wrecks degrade over time, with implications for the management of the thousands of other wrecks that lie on the ocean floor in shallower and less extreme environments. The rusticle bacteria identified at the Titanic site have been studied by microbiologists interested in iron-oxidizing organisms and their potential industrial applications. The geochemistry of the sediment around the wreck has been analyzed for what it reveals about the long-term fate of iron and other metals released by corroding wrecks. The Titanic has become, among other things, a laboratory. There is also the question of what lies around the Titanic that is not the Titanic. The debris field extends over a wide area of ocean floor, and its boundaries have not been fully mapped. Objects from the ship continue to be found at the edges of the known field. The sediment around the debris area has been sampled at only a few points. The biological communities surrounding the wreck, the organisms that live in the altered chemical environment created by a century of corrosion and organic matter input, have been studied only partially. The Titanic is the most famous object on the ocean floor, but it sits within an ecosystem that is itself a subject of ongoing research, an ecosystem that would not exist in its current form without the wreck, and that will change as the wreck continues to degrade. What happens to the rusticle communities when the iron they feed on is finally exhausted? What happens to the scavengers and the chemosynthetic bacteria when the organic matter of the debris field is gone? These questions will not be answered in our lifetimes, but they are being asked, and the Titanic is the site where the asking is possible. Rest now. The Titanic has been waiting for more than a century. It can wait a little longer. If this journey moved something in you, consider subscribing to Sleep on Deep. Every week, we descend a little further. The ocean is waiting.